If you've watched my other videos about graphing one period of a secant or cosecant function, there should be really no surprises in this one. So here's another secant one, just a little more complicated this time. So I'm going to begin by, just considering the graph of the reciprocal function. So I'm going to find the graph of 2 minus the cosine of 1/8 times x. So some things I want to note. First of all, I'm going to note that the amplitude of the cosine wave would just be 1, since that's the a value in this case. I'm going to note that the graph has been moved up 2, since there's a positive 2 k value. So my graph, my midline, will be moved up 2. Also, since that amplitude was negative, my graph will have been reflected this time. And then finally, it's going to be important to note the period of the graph. The period of the cosine function is 2 pi divided by the b value, which in this case is 1/8. 2 pi divided by 1/8 gets you 16 pi for the period. So using all that information, I should be able to get a quick sketch of what the cosine wave would look like. So then I can graph the secant function. So I'm going to begin just by looking at this, the positive axis, or the positive sections of my graph. Let's go ahead and get the y, or the x-axis labeled. So 0 is right here at the origin, of course. The period is 16 pi, so out here at the end I'll have 16 pi. And then, as we've always done, I'll need the halfway point, which is 8 pi, and then half of the halfway point, which is 4 pi, and then 3/4 of the way, which would be 12 pi right here. Okay, I'm going to label my midline as well, and then use my amplitude to get the y-axis figured out. So I noted that the graph had been moved up 2 spaces, so I'm going to go 1, 2, and then I'll draw this dashed line in here to represent the midline. There's going to be a lot of dashed lines with these problems, so you may want to use some different colors. The amplitude we said was 1, so from that midline I'm going to count up 1, so 3 will be an important point, and I'll count down 1, so 1 will be an important low point. Okay, so using all this, I'm going to graph the cosine function now. And then I remember this graph had been reflected, so while cosine normally starts from the high end, I'm now going to start the cosine from the low end. So right there will be my first point. From there it moves up to the midline. From there it gets to the high points. Next would be back to the midline, and finally I'll finish at the low point over here. And then if you had watched the last video, you'll recall that I actually also want to go back just a little bit. This is the one difference between a secant and a cosecant graph, at least how I do them. This point would just be the reflection of that coordinate over there, so this is negative pi over 4, and then that will be back up to the midline. The reason I do that, well, talk about it in a second. So let me go ahead and graph my cosine wave, and remember, I'm going to just do this as a dashed curve. Since the cosine wave isn't really the one I care about, it just helps me find where the secant wave is going to be. So, oops, I guess I don't really need an arrow. Alright, so anyways, at this point, one last step before I graph my secant wave. Every time that my cosine wave hits the midline, which is not the x-axis this time, but every time it hits that midline, there's going to be a vertical asymptote formed. So let me go ahead and draw those in. So there'll be a vertical asymptote here at 4 pi. There'll be a vertical asymptote here at 12 pi. This will be what sort of contains the u's, or what the u parts of the graph are trapped between. And the reason I added that -4 coordinate back over here was because that gets me a third asymptote. And so that helps me see one complete cycle versus just seeing half of one of those u shapes. So that's why I included that for my secant function. So now, after all this is done, since I haven't actually graphed anything that's visible yet, now I have enough things in place though to graph the actual function. So it's going to be a series of u's that's between all the asymptotes. The high or low point of the u is going to match up to wherever that cosine wave was. So there's going to be the first piece of the u, the next one would alternate, the next one would be up here. And oops, I missed that point right there. These should be the same coordinates, so 8 pi, 3 should be a coordinate on both of those, as well as 0, 1 should be a coordinate on both graphs. So there's one complete cycle. One complete period consists of an upper and a lower U-shaped graph. I can see that I have the start of another cycle formed over here. So I'll just maybe draw half of it in, although that would keep going forever, and I don't want to graph all of those, so I'm just going to stick with this. I do have one complete period showing with another little extra piece here on the side.